In the video on angles, we saw that there are 360 degrees in a circle and 2 pi radians. Now these may seem like crazy numbers. Why don't we use more reasonable numbers like 10 or 100 degrees? It turns out that people have proposed exactly that, and a lot of other numbers as well. But 360 and 2 pi have stuck for a reason. Let's look at each one, starting with degrees and then number 360. This number probably comes to us from the ancient Babylonians. Just as we feel comfortable today counting in tens, the Babylonians seem to have liked counting in sixes, although nobody is completely sure why. It was their practice to cut the circle up into 60 pieces, and that's still with us today. A minute has 60 seconds, and an hour has 60 minutes. The Babylonians used 6 and 60 in everything that they did. But apparently they sometimes found that cutting a circle into 60 pieces wasn't enough. They needed more pieces. Just as we might multiply the number of pieces by 10, they're into sixes, so they took their 60 pieces and multiplied them by 6, giving them the number 360. That's really all there is to it. They just multiplied together two of their favorite numbers, and out came 360. A great thing about 360, and probably the reason it stuck, is because if you chop something up into 360 pieces, you can gather together equal number of those pieces in lots of different ways. For example, suppose you have a party. You're not sure how many people are going to come, but you want to be prepared. So you get a cake, and before the party begins, you cut it up into 10 equal slices. How well is this going to work? Well, if one person shows up, they get all 10 slices, and that's fine. If 2 people show up, well, then each one gets 5 slices, and they're still sharing the cake perfectly. But if 3 people show up, you have a problem. The best you can do is to give 3 slices to each of the 3 people, and then there's 1 slice left over to fight over. And this is a situation we would like to avoid. We want to cut the circle up into so many pieces that we can give almost any number of people equal shares and have nothing left over. 360 does that just beautifully. Here's the cake looking from the top down. Let's cut this up into 360 equal pieces. Well, that's a lot of pieces, and they're very thin. In fact, they're probably hard to make out one from the other. So we will imagine that we have cut the circle up into these 360 pieces, but I won't draw them all. Now let's suppose that one person arrives at the party. Remember, our cake has been cut into 360 equal pieces. Well, that one person gets all 360 pieces. We take our 360 pieces, divide it by the number of people who have come, that's 1, and we get 360. So that person gets 360 pieces. I'll put a 1 on the right-hand side to remind us that we can serve one person without trouble. Now suppose we have 2 guests. We can divide 360 by 2 to get 180 pieces. So each guest gets 180 of the existing 360 pieces. They each get half the cake. There's nothing left over. Great. Now suppose we have 3 guests. 360 divided by 3 is 120. No fractions here. So everybody gets 120 slices. The cake is equally shared. Nothing is left over. How about 4 people? 360 divided by 4 is 90 with no fractions. Everyone gets a quarter of the cake. 5 people? No problem. 360 divided by 5 is 72. So everyone gets 72 pieces, and there's nothing left over. 6 people? 360 divided by 6 is, of course, just 60. So everyone gets a sixth of the cake. How about 7 people? And that's a problem. 360 divided by 7 is 51.43. So we could give each of our 7 people 51 slices. If you work it out, we have 3 slices left over for people to fight about. And that's too bad. So our scheme doesn't support 7. But let's try some of the other numbers. 8 works fine, because 360 divided by 8, that's 45 with no fractions. How about 9? That's great. And of course 10 works fine, because 360 divided by 10 is just 36. So if we cut our cake into 360 slices before the party begins, then we can have anywhere from 1 to 10 guests, except for 7, and we can give each guest an equal share of the cake with nothing left over. In general, being able to cut up a circle into all these differently sized pieces is very nice when we do geometry, either on paper or on the computer. Well, we can continue this process and check out larger and larger numbers of people at the party, and though 360 can't feed all of them equally, it still does a pretty good job. 360 is kind of the sweet spot for the number of pieces. It's not too big and it's not too small, but it serves lots of people well. Now, as I said, people have tried other numbers. In addition to the 360 degrees that we're familiar with, people have cut circles up into 400 grads. But 400 doesn't cut up into as many pieces as nicely as 360, so it didn't catch on. Of course, you can use any number of pieces you like and give it any name. You can say there's one Zixnork going around the circle. You could certainly do it, but it's probably not going to be any more popular than 360. So now let's turn our attention to radians. Where does pi come from, and why do we say that there are 2 pi radians? We will address those questions in part 2.